The test number 1 practice problem set, and I'm looking at question 59, where we need to select the correct graph of this piecewise function. So we need to pick one of these 5 figures to match up with this graph. So let me think about what that graph looks like. So I have g of x equal to 0 when x is equal to 0. So that must mean that there's a point right here on g of x. And 1 over x when x does not equal 0. And 1 over x looks like, let's see, that's going to go through the 0.11. And then as the numbers get bigger, that fraction, the numerator gets bigger. So it looks like that. But it's not defined at 0. But that's okay, because we got our definition of 0 right there. So that looks like, let's see. If I look at these figures, I'm going to zoom in a little here. That didn't help very much. But I'm looking at that 0.11, and I see that it crosses on that first figure, so that looks pretty good. The second figure, it doesn't cross at 1, 1. So when x equals 1, y should be 1, but that's not true in figure 2, and it's not true in figure 3. It's not true in figure 4 or 5. So all those 2, 3, 4, and 5 figures do not have, it's a little, the curve is not going to that 1, 1 point, so I know that's not it. So it's going to be figure 1. Okay, and then let's talk about the domain. So the domain of 1 over x is everything except x equal to 0. And our x equal to 0 is actually satisfied by that first piece of the piecewise function. So the domain is now all x's, all real numbers. So from negative infinity to infinity. Yep. And then the range, so that's going to be a open interval, because infinities always have open. And then the range is all possible x values, y values. So similar to the x, y can be, with 1 over x, y can be anything except for 0, but it's covered by 0 using this point right here. So range will also be negative infinity to infinity. So I'll select the open interval for that one. There we go. And then to determine where it's increasing, so where is it increasing? Remember, when we go to the increasing, decreasing, and constant intervals, we're always looking for the x values. We're always going from left to right. And we always have open intervals. So we can imagine our little guy walking along, and he's walking downhill. I mean, it's not much. It's not that steep of a hill. It looks kind of almost flat, but it's a little bit because it's approaching 0. So it is still decreasing. It's decreasing the entire time. It's decreasing on this line, and then now it turns into like a slide almost. It's so steep, and then when he comes back over here, he's still walking downhill. Now it's a really steep line, and then here he's still walking downhill. It's just not very steep. So at all places he's decreasing. So there's nowhere that it's increasing. And then decreasing is everywhere. So we go negative infinity. I think that actually from this point to this point, it's not decreasing. So It's decreasing on the left side all the way up to 0, but not including 0. And then it picks up decreasing again right after 0, and then on to infinity. So there's my decreasing. And then constant, it's never constant. I mean, he does like a jump to go from down here to up here, but he can stand right here, but he can never take a step. So there's no constant interval. So constant would also be nowhere. So I'll put in brown. So now I'm just going to enter all those 5 answers into the test. Okay, so I got everything inputted into the test question. Now I'm going to submit. And since it's a practice test, I find out immediately if my answer is correct. If it's not, I can always go over here to find the correct answer, or better yet, I can go down here and look at the hint or the solution, or where to find the information in the textbook. And I can check my work by the X's, mean I got it right, and there would be an X if I get one wrong. And there's the solution.